Good morning, class. Good morning to everyone. You're welcome to class today. This will be our first class for today, I believe. And I want to believe that we have all of our students in class at the moment. Please and please, you are required to listen attentively in class and follow through with the lesson that we have today. The objectives for today is to learn the use of the probability scale from 0 to 1 and also using fractions to describe probabilities. I'm sure you're going to have fun into this class. Okay, let's get right to it. We recall from the previous class that this was how we presented the probability scale. Impossible to the extreme left, certainty to the extreme right, and in the middle here we have the even chance, which is the 50-50 chance, okay, for an event to happen. Now, we use numbers to describe probabilities so that we can compare them, the probability of events that we would always have. Now, when we have an event to be impossible, we say that the probability is 0. And also when we have, you can say that in the probability scale, that is written as 0 right here for the impossible section. We're already moving from the, the words unlikely, likely, certain, impossible. We're moving into numbers to describe these probabilities now. So that means we will no more be talking about those names, okay? We will be using numbers to explain them now. So when an event is impossible, don't tell me it's impossible. Tell me that the probability, okay, is 0. All right. Now, if the event is definitely certain, that means it's going to happen, whether you like it or not, we say that the probability is 1. So in my probability scale, we change that to 1. No more words, but numbers now. If the event, is halfway, the even chance, the 50-50 chance, then we have a probability of 0.5, which is half. We know that from the words already that when it is halfway, a 50-50 chance, we say that it's equally likely to happen as they are not to happen, to not happen. Okay, so we're going to change the even in the middle here to the number half of 0.5. You'll be thinking that why we're using fraction, decimal. Yes, we use numbers to describe probabilities so that we can compare them, remember that, but we can write probabilities as fractions as well. So because of that, we can also write, don't let us take away that, we can also write as decimals. We'll get to that shortly. Look at my probability scale here, right here. You can see that extreme left is 0, extreme right is 1, in the middle I have fractions. This is a scale of 4, so I think I have 1/4, 1/2, 3/4. Now you understand that this 1/2 could have also been seen definitely as 2 out of 4, okay? You can have it that way as well, 2 out of 4. 2/4 definitely is the same thing as 1/2. Just for you to look at and see how the scale is going, on a scale of 4, I have 0 starting from 0, then 1 out of 4, 2 out of 4, which something as half, 3 out of 4, then 4 out of 4 is the same thing, as 1. So if you write it as 4 out of 4, you still have exactly the same thing as 1. Okay, just to take a look at that. Now, very quickly, we also, can write probabilities, just like I mentioned, as decimals. A probability of 0.1, you can see it right here, that 0.1 is definitely close to 0. That's the impossible. So definitely a probability of 0.1 is very unlikely. Let's take a look at the probability of 0.8. Probability of 0.8 is actually quite close to 1, which is certainty. So definitely a probability of 0.8 is quite likely to happen, okay? So that's trying to tell us what these numbers mean, all right, when we are dealing with probability, okay? Guys, we can also write probabilities as percentages. So that can be seen in the probability scale up there from 0% to 100%. Okay, you can see that this is a scale of, let's say, a scale of, 10 as well, because I can see 10 here. 1 over 10, 2 over 10, 3 over 10, and so on and so forth. And in percentages, we have it this way. A probability of 50% definitely we know is even, so 50-50, and a probability of 100% is certain. That means the event will surely happen. Okay, moving on. We want to take a look at the case of a guy named Ryan, who happened to come in contact with a bag of sweets. In this bag, there are 10 sweets. Ryan takes one out and eats it. What is the probability that it is red? Okay, I'm going to quickly go into a very important aspect of simple probability. And that is something that you must take to heart very quickly and understand very fast, because it is the basis of this topic. Now, the probability, okay, of an event is basically all the time written like this. So if I write P bracket E, which you're seeing on your screen, okay, this means in words, okay, the probability, we'll get into that in another class, of an event or whatever event that we are talking about. For instance, in today's class, Ryan picking out a sweet, and the sweet to be a red sweet is the event we are dealing with here. After talking about the meaning of probability of an event, that's what the short form of writing the probability of an event as P bracket E. Then we also need to talk about the probability of any event E, just like we have mentioned, the probability of any event E, okay, generally, so that you can follow through with all my examples and understand how these answers are derived, okay, which makes a lot of sense when you are writing your probabilities. We can define it as the number, okay, as the number of required outcomes divided, okay, divided, that's all over, divided by, okay, total number of possible outcomes, okay, possible outcomes. All right, what this is talking about basically is for us to know that there is a formula for calculating the probability of any event. And this is the formula you are looking at right now on your screen. This formula, guys, take note, is very, very necessary for us to understand. Now, what do I mean? When I talk about required outcomes, okay, when I talk about required outcomes, which is the one that I have, all right, the one I have in my numerator right here, okay, this one, required outcomes. Guys, required outcomes is really talking about what the question is referring to. Now, in this case of this example, you can see that we are talking about the probability that it is red. red sweet is the required outcome. That Ryan picks or takes a red sweet. That is the required outcome. In other word, we can call required outcomes, we can call it successful outcomes. Okay, that's another word for it. Successful outcome. Now, the success that we want from this question, for example, is that Ryan takes a red sweet. Success is red. Okay, required, you can also use the word required. Required is red. Now, guys, the formula for the probability is not just required outcomes over possible outcomes. It is the number of required outcomes. So if my required outcome in this event is a red sweet, then the number of red sweets is the number of my required outcomes. So the question you're going to have to ask yourself is, how many red sweets do you have in this bag? Of course, you can see that we have 5 red sweets. So if I come down here and then have the probability of, let me just put it as Ryan picking a red sweet. Let me just call it a red. I'm expecting my answer to be equal to, so number of required outcomes, how many red sweets are there? 5. Divided by total number of possible outcomes. Now, the total number of possible outcomes talks about the total number of sweets in this bag. In the case of tossing a coin, the total number of possible outcomes is how many faces do you have on a coin? Definitely 2. So that means you can only have 2 possible outcomes. For the case of a fair dice, okay, the one you use to play on your Ludo and you know, those dice, you know, it has 6 faces and there are 6 numbers all around it. So that simply means that your total number of possible outcomes for a fair dice is 6, okay? So that's how we take a look at it. Everything is a total number of possible outcomes. So in this bag, there are 10 sweets, so which means my total number of possible outcomes is 10. So the probability that Ryan takes a red sweet is 5 over 10, which can definitely reduce to 1 over 2. Half. Very interesting, guys. You need to understand this to proceed with the lesson. Now, I'm going to take this away very quickly. Okay, so I already talked about required outcomes, and I've also talked about possible outcomes, and I've explained what they mean. Okay, so I'm going to take it away. I'm going to take my writings away. Please, I want to believe that you've actually taken note of that. Write it somewhere so that you always remember and be able to apply it to calculating the probabilities of events. So that goes away, and then we continue with what we have here. So if we proceed, we'll say that 5 out of 10 are red, just like I explained, and this is half of the sweet. So the probability of getting red is 1 over 2, or simply 5 over 10, which has been reduced to 1 over 2. So if we put it on a probability scale of decimal numbers, you can see right here, red is pointing to 0.5. Now, guys, what is the probability that the sweet that Ryan takes out and eats is a blue this time around, a blue sweet? All I have to do is to take a look at the number of blue sweets in the bag. So the probability is going to be how many? 1, 2, 3 blue sweets. So 3 over 10, 3 out of 10. So 3 out of 10 is 3 over 10. So if you do that, that can still give you 0.3. In fraction is 3 over 10. In decimal is 0.3. Putting it on the probability scale, we have the blue. Right here, pointing at 0.3 on my probability scale. Let's take a look at another color, white, I think. Yes. What is the probability that it is white, that sweet is white? The probability it is white is, of course, as you can see in the bag, we have 2 white sweets, so that is 2 over 10, 2 out of 10. 2 over 10 definitely should reduce to 1 over 5, and 1 over 5 in decimal is 0.2. Showing that on our probability scale right here, white is pointing at 0.2. And that is how that goes. Okay, let's move on, guys. Now, here we have this. A fair six-sided dice is rolled. That was a fair dice I was talking about the other time. Now, question A here talks about 1. What is the probability of rolling a 1? That the dice, when you roll it, it shows up 1 for you. What is the probability? And we have other questions right here. We're going to need to drag all those guys to the probability scales, all those pointers, to point to where exactly they should be on the probability scale. Okay, all right, at this point, I'm going to allow you to fill in those places. I'll give you like 2 minutes, okay? Fill in the probabilities that you have over there based on my explanation of how to find the probability of any event. So please do that, guys, very quickly. In just 1 minute is even enough for you to do this, and then you are good to go. The first one talks about getting a 1 on a dice. The second one talks about an even number. Okay, remember, probability of required outcome over what? Possible outcome. But the number, okay? Number of required outcome over total number of possible outcomes. For a dice, total number of possible outcomes is 6, remember? But the question is, my required is to get a 1. So how many 1s do I have on my fair dice? Of course. Without wasting time, there's only one. Okay, there's only one of this one face on the fair dice. So definitely out of 6, that will be 1/6 over there. 1/6 based on a 6 scale. 1/6 should actually be somewhere here. 1/6 should be somewhere here. Yes, that's correct. If I take a look at an even number, guys, how many even numbers do you have on a fair dice? Of course, I think it's just 2, 4, and 6. So there are 3 even numbers. Okay, so since there are 3 even numbers, the number of my required outcome, because required is even numbers, and I know that there are 3 of them, so that's going to be 3/6. But because we need to always take note, leave our answers, okay, in their lowest terms, 3/6 can still reduce to 1/2, okay, when you reduce that to its lowest term. So of course I can drag my B. 1/2 is half on the probability scale, and that is correct. If you look at the next one, I'm sure you guys have done it already. We're just confirming our answers. Look at the next one, less than 5. Okay, the required outcome we want is numbers that are less than 5 on our fair dice. How many are those? 1, 2, 3, 4. So there are 4 numbers that are less than 5. So that means this should be 4/6. But just like I said, we can't leave our answer this way. We must always leave our answer in their lowest terms. So if you reduce 4/6, you should get 2/3. Okay, so 2/3 on the probability scale should be somewhere here. Exactly, and that's correct. Finally, the probability of rolling a multiple of 3. Now, multiple of 3, when you hear multiples, it's actually just talking about your multiplication table. So if you look at your multiplication table of 3, okay, you have 3 times 1 is 3. So 3 is a multiple of 3. 3 times 2 is 6. So 6 is a multiple of 3. So definitely on a fair dice, guys, 3 times 3 is 9, but I can't get a 9 on this fair dice. So definitely the only numbers that are multiples of 3 on these dice are 3 and 6. So that is 2 numbers, 3 and 6. And that is 2/6. But I'm sure we already know that we can't leave the answer this way. We have to take the lowest term. And taking the lowest term for that is 1, definitely 1/3. So where do we have 1/3 on our probability scale? 1/3. 1/3 can also be seen based on a 6 kill as, just like I wrote before, 2 out of 6. So that should come somewhere here. 2 out of 6. Exactly. And that is correct. So if we mark our result, we have everything correct. All correct. Well done, guys. Well done. Okay, moving on. Now we have another type of question. What is the probability of getting each color in these bags of sweet? Each color. So probability for getting a white. Of course, we know how this goes already now. How many whites are there? So definitely that is 1. Okay, how many total number of sweets do we have in the bag? I think we have 5. I can see 5. So that's 1/5 for white. For blue, oh, I'm going to have 4/5. There are 4 blues there. Oh, sorry, 4/5. For the second bag, 1, 2, 3, 4, 5, 6, 7. There are 7 whites. There are 7 sweets in total inside the second bag. 7. So that means how many whites are there? So that should be 3 out of 7. How many blues are there? I still have 3 blues, so 3 out of 7. How many reds are there? I have 1, so that's 1 out of 7. And that is how these probabilities go. We mark it, we have correct, all correct again. Well done. So that is how that goes, guys. Moving on. This is a spinner, guys. The sections are equal in size. Each color is equally likely to come up. If you spin it 15 times, how many of each color would you expect to get? Well, from expectations, according to probability, since each of this color has equal chance, okay, of coming up, all we need to do is to count 1, 2, 3, 4, 5. Total number of colors is 5. And then if I want to talk about the expectation of getting this yellow, the question is how many yellows are there? 1. So my expectation is 1/5 as a probability of getting a yellow. 1/5, 1 out of 5. That's my expectation. Okay. Now, let's click and spin and see what happens. I'm going to come here and spin the spinner, spin. Okay. I've spun twice. I have 1 white. The 3rd time, I have a yellow. It's going to spin again the 4th time. Okay. Pink again. It's going to spin again the 5th time. Okay. All right. Okay. Blue for the 5th time. We keep going. The 6th time we have pink. We're spinning again. The 7th time we have pink again. Oh, okay, that was blue. And the 8th time we spin again. We spin again the 8th time. Okay, and we're having a little bit of network. Okay, spinned already. Pink again, pink again. The 9th time, what do we have? Oh, I think we have purple this time around. It was purple then as well. White this time around. So 2 white, 10th. The 11th spin is coming up very shortly. Okay. All right. Yes, okay, we have the 11th pin. I think which one? Okay, white for the 11th pin. The 12th one, white again. So 4 for white now, 4 for pink. 13th we have pink again. 5 for pink. Okay, white again. 14th spin. We have and the final one. Let's go. The final spin gives us the yellow. Oh, no, that was for the 14th. Okay, yellow again for the final spin. So we have this result. Now, is this what you expected to happen? Remember we said our expectation was 1 out of 5. as the probability of getting each of these colors. Okay, and 1 over 5 of 15 is definitely 3. So our expectation is that if we spin 15 times, each of these colors should come up 3 times. But that is not the case. So we need to understand that we would always not get, you would expect to get 3 of each color, but it doesn't always, work out exactly as you expect. The more you spin it, the more the numbers should equal out, okay? It's supposed to be 3, 3, 3, 3, 3 for each of those colors, but it's because we did a small number of spins. So if we try to increase the number of spins, if you take it to 50 spins, can you see the numbers are closing up? If you take it to 150 spins, can you see the numbers are closing up? 1,000 spins, if you take it to 1,000 spins, okay, we're going to have, you see, okay, let me take that again, 200 to very close. They are all very close. So the more spins you do, the better the estimated probability that you get. Okay. All right, let's move on. Here's another spinner, guys. Some of the colors are repeated. So there's an equal chance that the spinner will stop on each section. So let's see what happens next if we decide to spin. Okay, now just like I told you about expectations, about probabilities, if we take a look at this spinner, I have a total number of 8 colors, 3 out of which are pink, 4 out of which are yellow, and 1 is blue. So if I need a probability that is going to stop on blue, it's going to be 1 because there's only 1 blue. Then out of how many altogether? 8. What is the probability that it's going to be pink? Oh, I just need to, how many pinks are there? Okay, I'm going to put 3 pinks out of a total of 8. And the yellow, I have 4 yellow out of a total of 8. But please take note, guys, we always have to write in their lowest form. So 4 out of 8 can still be written as 1 over 2 when it is reduced to its lowest form. Let's make use of our probability scale. So this goes to 1 over 8, 1 out of 8. If I break it down to 8, 1 out of 8 will start from here. 3 out of 8, okay, sorry, 3 out of 8 should be here. Okay, and then 1 over 2 should definitely be here. And that is correct. So guys, let's mark it. All correct. Well done. Moving on. Now, we will need to fill in the probabilities for these spinners. We want to fill in the probabilities for these spinners. Okay. I'm sure we all can see. Basically, I have a total of 4, and then there's 1 pink, and there's 3 yellows. So for pink, it should be 1 over 4. For yellow, it should be 3 over 4. For pink, for this second one, spinner, there are 2 pinks, but I have it out of a total of 6 colors. So 2 over 6. For yellow, it has to be 3 over 6. And then for blue, it has to be 1 over 6. Remember reducing to their lowest terms. So 2 over 6 should go down to 2 over 6 should go down to 1 over 3. Okay. And then 3 over 6 should go down to 1 over 2. For the last spinner, I have 8 colors altogether, out of which 5 are pink. So I'm going to have 5 over 8. 2 are yellow, so 2 over 8, which reduces to 1 over 4. For blue, I have only 1, so that's 1 over 8. So let me reduce yellow to 1 over 4 to its lowest term. And then if we mark it, we expect to have all correct again. Well done, guys. I think we're getting this now. We're getting the hang of this. Moving on. Now here, see, Tom has two spinners, okay? On which spinner is he most likely to get pink? On which spinner is he most likely to get pink? What you need to do here right now is you need to find the probability of getting a pink from spinner A and the probability of getting a pink from spinner B, and check which one is most likely. And then you pick your answer. So guys, this is an activity for us to do in today's class, and you're going to have to do it now, okay? What I expect from you very quickly is you need to definitely go to your page right now on Edmodo, okay? Go to your page, you would see a link, all right? That link, you need to click on the link. It opens up a Padlet for you. On this empty space of that Padlet, you double click, okay? When you double click, it's gonna show you where you're gonna write your answer. Please, on that Padlet, you have, let me just quickly show you what I'm talking about. Quickly show you what I'm talking about. Sorry about that. This is, for instance, what you will see. For the first one, we are supposed to have, this is the first one you are making use of. Okay, this is how it's going to show up on your screen when you click on that link. And then when you double click, it shows this up. Your title should be your name. Let's assume your name is Ryan. Put your name here. And then you come to write something. That is where you put in your answer for me. If your answer is A, just write A. If your answer is B, just write B, just like that. And once you are done, you click the empty space and then you leave it that way. So I need your responses, guys, this way. Let's go back to the class. I need your responses, okay? I need your responses this way to this particular question. The question is, on which spinner is he most likely to get a pink? All right, send in your results, guys, quickly, send in your results. I am waiting. Send in your results, send in your results. Okay, send in your results. All right. The link you are using for this first question you are looking at on your screen has a tag on it. Check that link. Is meant to be for the first question, Soluki. Okay, that's what you are using. I have three Padlets, Soluki, then there's Soluki 1, and then there's Soluki 2. Soluki 1, Soluki without any number, is for this one right here on your screen. We have more questions coming, which you will use Soluki 1, and you also use Soluki 2, sorry, and then Soluki 3 to put in your answers for that. I'm sure you are sending in your answers to my Padlet now. I'm seeing them as you are sending them. So keep sending them. I'll be right back. Now, this is Ashley. Ashley says, for the two spinners you're looking at, Ashley says, I am more likely than Elaine to spin a 3. Okay, so Elaine is saying, I don't know. So let's find out if Ashley is correct. So on a paper, can you write down reasons why Ashley is correct? So that means Ashley is correct. We just need to tell us the reason why Ashley is correct. Okay, tell us the reason. So put this answer on Padlet 2. That is Soluki 2. Put this answer on Soluki 2. You see it there? All the Padlets that you have already have their questions, so you know which one you're supposed to answer. So this one is actually for Padlet Soluki 2 that I've created. Okay. Now, this is another set of spinners, but this time around, for these two new spinners, Ellen is now saying that we are both equally likely to spin an even number. Okay, I need you to write down reasons why Ellen is correct. Write down reasons why Ellen is correct. Put it on the third Padlet. The third Padlet has Soluki 3. So this is for Soluki 3. So put the result there and send to me. I will be seeing all your responses immediately as you are sending them. So it's real time, real time. I'll be seeing them. So send your responses very quickly, okay? Okay, thank you very much, guys. I've received all your responses and I've responded to them. I gave the stars to tell you that you're correct or you're almost correct Your explanation is good, fantastic. It's all about probabilities, guys. Thank you for your responses on the Padlet. I was able to see all your contributions in today's class. It has been interesting so far, very, very interesting. So please take note that the responses that you gave are all taking note of, and the school is actually taking note of them as well. It is important that you are always contributing in class. Very, very important. Ladies and gentlemen, guys, this brings us to the end of today's class. I'm going to see you again in the next class with a beautiful session. Thank you very much, and see you soon. Bye.